All right, thank you for joining us. Here we'll do some practice problems involving solving polynomial inequalities and rational inequalities. For all of these, it will be most helpful if you can draw a basic graph. So for example, if we look at this first one, we consider what we have. We know that we have a parabola that opens upwards, and we have two real roots. Right? So if we want the solution for when that parabola is below the x-axis, we know the solution will be if a is less than x is less than b, and then we just have to identify, well, what's the value of a, what's the value of b, what are the critical values we were working with. So in this case, we're going to have that -3, that's going to be the value on the left, is less than x, which is less than 4. That's going to be my solution because I understand my basic graph. Here we have x minus 1, 3x minus 4 less than or equal to 0. So once again, parabola opens upwards because of positive leading coefficient, right? And between a and b, less than or equal to 0 means that I am going to be between a and b inclusive. Maybe I want to give it using this notation. And of course, my root here would be if x is equal to 1. My root here would be x is equal to 4/3. So between 1 and 4/3, 4/3 is on the right. So my solution set is going to be from 1 to 4/3. Okay, I will have 32 plus 4x minus x squared is greater than or equal to 0. Well, leading coefficient is negative, so I know I open downwards, and my interval, once again, if I call this a and b, my interval will be such that a is less than or equal to x is less than or equal to b. Right? I just have to be able to set up and solve for what those critical values are. So 32 plus 4x minus x squared, if I'm going to rearrange this equation, I could say that move the x squared to the other side. So I could say that 0 is going to be greater than or equal to x squared minus 4x. X squared minus 4x plus 32. And in that sense, I'm still looking at the exact same interval. So I need two numbers that multiply to be, and this should not be plus 32, this should be minus 32. So I need two numbers to multiply to be 32, but have a difference of 4. And so this would be x minus 8 and x plus 4. And so I know that that's going to be my critical values. So the one on the left, I'd have -4 less than or equal to x less than or equal to positive 8. There would be my solution. Okay. Here we have x squared plus 16x plus 24 is greater than 6x. So let's compare to 0 because we're going to need to compare to 0. So x squared plus 10x plus 24 is greater than 0. That is positive leading coefficient. Intersections, I want when I'm greater than 0, so I know it's going to be if x is less than a, or x is greater than b. Okay, so look to my critical values. I can factor this as x plus 6 times x plus 4. And on the number line, I know that -6 is to the left of -4. So that means my solutions are going to be when x is less than -6 or x is greater than -4. All right. Being able to understand the basics of your graphs will make work a lot easier. So here we have a cubic function. All right. So we have a cubic function. Let's compare it to 0 once again. So I have 2x cubed plus 5x squared minus 6x minus 9, and that needs to be less than 0. So I need to figure out, right, when does this function equal 0? In general, I know that my graph can look like that, and I don't know if I'm going to have one real root or maybe I have a double root, but I can determine my solutions by using my past content. All right. So using my past content, I can try to use the factor theorem or the remainder theorem, and I can say, hey, if I substitute in 1, so if I substitute in 1, I'm going to have 2 plus 5 minus 6 minus 9. So that's not 0, so I know x equals 1 is not a root. But I could also try negative 1. If I substitute in negative 1, that'd be negative 2. Let's see here. So I'd have negative 2 plus 5 plus 6 minus 9. So that does equal 0. So therefore, x equals negative 1 is a root. Right? I can always try positive 1 and negative 1 using my factor theorem. And so now if I do synthetic division, so here's negative 1, synthetic division, I have 2, 5, negative 6, negative 9. Do the synthetic division, bring down the 2, multiply, add, multiply, add, multiply, and I know I should get 0. Then I know that my factored form is going to be x plus 1 times 2x squared plus 3x minus 9 being equal to 0. Now, the 2x squared, that can factor as 2x and x, and actually this needs to be less than 0. All right, so I then have x plus 1. All right, so 2x and x, so we can try to think through what might happen here. So I need numbers that multiply to be 9. But then I'm going to, within the product, have a difference of 3, positive 3. So if I put a plus 3 here, that's 2x and 3 is 6x, and a minus 3 there, that works. And if that's going to be less than 0, I can use line analysis and say I'm going to have, let's see here, negative 1 as a root, 3 halves as a root, and negative 3 as a root. All right, so on a number line, there's negative 3, there's negative 1, there's 3 halves, and I know that my graph has to look a little something like that. And if I want to know when I'm going to be less than 0, that's going to be when x is less than negative 3, or when x is between negative 1 and positive 3 halves. All right, so why did we go over the emphasis on drawing your graphs, understanding the basics? Because that's how we can then solve inequalities more rapidly. So we'll look to the next one. X cubed minus 2x squared minus 9x minus 2 is greater than or equal to negative 20. So same thing. Let's rewrite this. X cubed minus 2x squared minus 9x, add 20, so that's going to be plus 18. That's going to be greater than or equal to 0, right? And while the last one didn't factor by grouping well, it looks like this one possibly might. And so let's see, if I factor out an x squared, that gives me an x minus 2. And if I factor out a negative 9, so minus 9, that gives me an x minus 2, right? My inequality holds. In general, I know, same thing, the basic shape of my graph. And it seems like I might have 3 solutions. So if I continue this factored form, that's going to be x squared minus 9 times x minus 2 being greater than or equal to 0. So that means I have x plus 3, x minus 3, and x minus 2 being greater than or equal to 0. On a number line, negative 3 is going to be furthest left, then positive 2, then positive 3. And we already talked about the basics of the graph, right? And the basics of the graph is that we're going to look a little something like that. And I want to be greater than or equal to 0. So that's going to be as long as I am greater than or equal to negative 3, less than or equal to 2, or if I am greater than or equal to 3, but less than infinity. All right. If you want to do it with an inequality, you're welcome to, but there is solving polynomial inequalities with some quadratics and with some cubics. Understanding our graphs, very, very important. Please ask questions for clarification when needed.